Hello. Now we're going to discuss vertical asymptotes and infinite limits, which they pretty much tie together, more or less, or at least infinite. A vertical asymptote can be thought of as an infinite limit at a finite point, where f of a finite point c where f of x goes crazy. In particular, it's a finite point x equals c such that f of x gets crazy as x gets close to c. So more formally, let a be less than b and let c be an element of the closed interval ab. Let d be a subset of the reals that is a superset of the deleted open interval. Of the deleted, not deleted open interval, of the deleted interval, of the deleted closed interval ab with c taken out of it. So it's the deleted closed interval. Now c could be in d. It doesn't have to be in d. It might or might not be. Well, we know c is obviously not in this by its very definition is the closed interval ab with c plucked out of it. We do allow for the possibility that c could either equal a or that c could equal b, but that's not promised. It could equal one or the other or neither. But anyway, that's not really going to help or hurt us in this definition here. Suppose that the limit x goes to c of f of x does not exist but remains predictable, and that f of x gets arbitrarily large in the positive sense as x gets arbitrarily close to c, i.e. the graph of f of x goes arbitrarily high up the positive y direction, or in the positive y sense, as x gets arbitrarily close to c. Then we say that the limit x goes to c of f of x equals plus infinity, or, and remember I interchangeably use plus infinity and just infinity, okay? But anyway, so what's happening is, guys, as x is getting close to c, f of x is going crazy. As x gets, now, we're not going to let x equal c. Remember, the limit doesn't necessarily, we don't necessarily even care. For all we know, f of c could equal 2. We don't know how f is behaving at c. F of c may not even be defined at all, but depending on if c is in d or not. We don't care how we behave at x equals c, but as x gets arbitrarily close to c without touching, what f of x is going high up in the sky. It's going indefinitely high up in the sky. It's the closer we get to c, the more steep our graph of f of x is getting, and it's going to get arbitrarily big. And for example, if c equals 5, then let's just say that c equals 5 and f of x is going crazy at c equals 5. Let's just say I've got 1 over, let's say I've got a fraction, 1's in the numerator and x minus 5 is in the denominator, and f of x equals that fraction. As x gets close to 5, f of x is going to go crazy toward, no, that's not a good example. Let's do this instead. Let's do 1 over 1 in the numerator and parentheses x minus 5 close parentheses squared in the denominator, where x minus 5, we're squaring the whole thing x minus 5. So we do x minus 5, we get that result, then we square it. It's parentheses x minus 5 squared on the bottom. Then f of x would remain predictable as x gets close to 5. F of x would go toward positive infinity, right? So if I did, and I'll insert that here, no harm. I'll try not to, you can't hear me type, I hope. Let me just give you an example. F of x equals 1 over, like I talked about, x minus 5 parentheses squared. And then like that. Okay, so that would be an example. As x gets close to 5, f of x is going toward positive infinity. What I mean by going toward positive infinity, f of x is getting bigger without bound. It really, at the end of the day, there is no real number on the y-axis called positive infinity. But what we mean by that is x is getting close to 5 from either direction. It doesn't matter if it's from the left or from the right. As x is getting close to 5, f of x is getting big, fast, and definitely bigger and bigger. And as you get super duper close to 5, f of x is way high up in the sky, in the y direction. So that's that. And notice it doesn't matter, that square is going to kill any negative anyway, so you're going to go toward positive infinity. and that's from either side. And as far as the domain for this guy goes, you could just let the domain be any real number except 5. So the D here could be, let's just say, the real number's minus 5. But anyway. And in a similar fashion down here, now, what if instead of going high up, what if we remain predictable? What if f of x goes forever down as we get close to C from either side if we're interior? And when I need to be careful, in general, this is just an example, guys. In general, if C equals A, then remember we define the overall limit to just be the limit from the right, because the limit from the left wouldn't make sense if C equals A. And if C equals B, we define the overall limit to be the limit from the left, because the right-hand limit, the limit from the right, wouldn't make sense. It wouldn't make any sense. So the overall limit, in the event that C equals B, is just the left-hand limit, and the overall limit, if C happens to equal A, is just the right-hand limit. Now, if C is an interior point that's in between A and B but doesn't equal A itself nor B itself, then for what we're saying is if you come at C from either side right here, it's understood to be from either side. That's kind of in a subliminal message in the woodwork right here. Then if you come to C from either side, f of x is going to go high up in the sky. Doesn't matter which side you come at C from, if C is an interior point. Just taking care of the subtleties there, okay? And in a similar fashion, if C goes down instead of up, as you come into C from either side, if C is interior, or, if C is an endpoint, you take care of it the way you took care of it up here. If you go arbitrarily far down along the negative y direction, I don't want to say axis, I want to say direction. If you go arbitrarily far down the negative y direction, as x gets arbitrarily close to C, f of x is getting arbitrarily negative big, like a negative trillion, or even bigger in magnitude, absolute value, or in a number whose negativity is very vast. So like negative big means like negative trillion. So as x gets close to C, f of x is getting negative big, that informally. So you'll go to a negative trillion and beyond. You'll keep on going down the negative y direction. Then the limit is equal to negative infinity. And again, to do an example of that, it's not hard. I don't have to be all that creative either. I'll just use what I used up there, but with one little slight modification, I'll stick a negative in front. And that's all. And again, C equals 5 would be my crazy guy here, right? And I could let D be all real numbers except 5. 5 is where I go crazy. So now really, and you're like, well, Jason, what about, if C is in D? That's a little funky. Guys, if C is in D, then we're going to have to define f of C to be a finite value, but that's not going to mess us up. The point is we're getting arbitrarily either positive big or negative big as x gets close to C but doesn't hit C. We don't promise what happens when x equals C. We don't even promise that f is defined when x equals C. We don't promise, what f equals when x equals C, even if it is defined. So the point is, f of C could just equal 2 or something, like that. But as x gets close to C, f of x is going crazy. And these limits are going up either to positive infinity forever in this sense, as we come into C from either side, if C is interior, or from one side if C is endpoint. But anyway, and in a similar fashion, we're going down to negative infinity here. Now, guys, to be a vertical asymptote, it's nice to do things from both sides. Now, yeah, we need to do things from both sides. Never mind. Let me not go there. So what if, now let me go to this third bullet point. Suppose A is less than B, and now this time, suppose that C is in the half open, half closed interval AB, where A is not included, but B is included. And again, let D, have a similar role play that it did before. And let F be a function from D to R. Now let's just say we're wanting to do one-sided is what it boils down to. Suppose that as x gets arbitrarily close to c from the left, you can see why I don't want a in there. Suppose that as x gets arbitrarily close to c from the left, that f of x goes crazy, but in a predictable way. Guys, in these first 2 bullet points, we were going crazy, but it was in a predictable way. We're only going in one direction. Like here, we were going in we're only going in one let me back up. We're only going in one y direction. As we come into C from the appropriate side, if we're an endpoint, or from either side if we're an interior point, then we're going up to positive infinity here, just positive infinity. And we're going down to negative infinity here, and just negative infinity. It depends if you got this scenario or this separate scenario here, okay? You can't have a graph that zigzags up to positive infinity and then zigzags back down toward negative infinity. We're not allowing that. We don't want that kind of graph. We want a graph that's predictable, but still gets crazy in that it goes in one direction, one chosen direction. You pick that direction and you stay in that direction. And you go forever in that direction as x gets arbitrarily close to c. And this was from either side if we're in an interior point. This right here, we just want to come in from the left. So really, B isn't anything special here because we just come into it from the left anyway. So if it happened to be the case that C equals B, that is. If C equals B, then we're coming in from the left anyway, so that's nothing special. And if C is an interior point, then that's fine too. So suppose that the limit as x goes to c minus of f of x does not exist, but remains predictable in that f of x gets arbitrarily large in the positive sense as x gets arbitrarily close to c from the left, i.e. the graph of f of x goes arbitrarily high up the positive y direction as x gets arbitrarily close to c, but not equal to c, mind you, from the left. Then we say that the limit as x goes to c minus of f of x equals positive infinity. Big surprise, right? It's just the consistent notation, or this, depending on which one I'm in the mood to use. In calculus class, you'll need to stick with the one your professor chooses if he prefers this one, or if he or she prefers this one, or if she or he prefers this one. Just stick with the notation that he or she would prefer. Okay. So in a similar fashion, we can come in. If you can go down to negative infinity. We're still coming in from the left in this next example, which I need to move to the next page just to make it organizationally nice to look at. But again, we're coming in from the left, but the difference is we're going down to negative infinity. That's the only thing different about this one right here. We're just going to negative infinity. Now in these next two, we're going to come in from the right. And now we're going to include A, but not include B, and we're going to, because we allow the possibility that C could equal A. It might not, but it might. But the limit as x goes to C from the right of f of x, suppose that limit doesn't really exist, but it's predictable in that f of x gets arbitrarily large in just the positive sense, and it goes the same old way. So as we're coming in to C from the right, f is going way high up in the sky in the positive y direction. Then the limit x goes to C plus of f of x equals positive infinity. And then in a similar fashion, you can do the same thing for negative infinity in an analogous fashion. Now, x equals c is the vertical asymptote. And you know what? These one-sided examples, you could just go, if you wanted to do a concrete example, or these one-sided cases, I should say, not examples, these one-sided cases, you could, if you wanted a concrete example, like here, c equaled 5, right? And you could just go down here. If you wanted to do a one-sided case, you don't have to use a lot of imagination. You could just do the same function. For positive infinity, you'd want to use this one, right? Because it's positive infinity. You could just do and I'm going to paste it. Just do the same function. That's just a concrete example. These 1 over x minus 5 squares, guys, they're just concrete examples, okay? I just wanted something concrete for you to get your hands on. There's a buku of examples you could come up with. But anyway, the x equals 5 would be the vertical asymptote. Now, so let me just put x equals 5 I'm going to call it VA for vertical asymptote. I'm being lazy. This VA stands for vertical asymptote here, so allow me to be lazy. But anyway, there's that. And likewise, it is here too. And it is for all these. It's my vertical asymptote for all these, okay? I just don't feel like going through and labeling them all. But it is up here. It is here in this guy. I didn't label this one, but it is up here too. It is here. It is here. And if there's any ones up top, it is for them too. Well, no, that's it, isn't it? Oops. So it is here. It is here. It is here. It's the vertical asymptote. X equals 5 is the vertical asymptote here. X equals 5 is the vertical asymptote here. X equals 5 is the vertical asymptote here. And so on and so, just for these examples. Now, in general, I'm not saying, in general, we don't know what, we could have a trillion different examples. You could have one example where C equals, 6 or negative 12 or 1/5 or 1/3. C could be a lot of things, guys. C can be 0 as well, So C could be a lot of things. But in this particular, this is just example, right? This is just an example. So, okay, but anyway. Now there's that, and there's that. So, and I did the one-sided cases, and here's an example. The limit as x goes to 0 from the right of 1 over f of x equals positive infinity. We go up, while the limit x goes to 0 minus of 1 over x is negative infinity. You know what? These limits don't agree, so the overall limit does not exist in any form. We can't set it equal to either infinity. Now, if I had done 1 over x squared, I don't think I did. No, I didn't. But I'm running out of time here, but let me see. If I wanted to do, let me try to type if it will let me, excuse me for the silence there, but let me try to type c equals 0, right? In this case, x equals 0 is my vertical asymptote. That's where I go. Things go crazy. So the limit x goes to 0 of, now 1 over x squared, now that equals positive infinity because we square away any negatives that would have occurred. So we go up from both directions. As x comes into 0 from either direction, we're going up. So this limit, quote unquote, it exists in the directional sense in that it equals positive infinity. It doesn't exist in the truest, bluest sense, the truest, deepest sense, but it exists in the directional sense in that it equals positive infinity. This right here, this ordinary limit of 1 over x, it doesn't even exist in the directional sense. We can't even say it's equal to positive or negative infinity. It's over. It just plain doesn't exist right here in any sense or form. Okay? That's all for this video, guys. Thank you. That was vertical asymptotes.